In 1960, Chrysler tilted an engine 30 degrees to the right and created the most indestructible power plant in American automotive history. An inline six so overbuilt, it became folklore. So reliable that mechanics called it unkillable. So durable, it outlasted the cars it was bolted into. Twice. This is the story of the Slant Six, the engine that refused to die. Picture a 1965 Plymouth Valiant idling in a New England driveway on a February morning, 20 below zero, no block heater, just a twist of the key and that familiar mechanical hum. Steady, impossibly alive. Under the hood sits 225 cubic inches of cast iron leaning hard to the right. The Slant Six. Chrysler's answer to a question nobody thought to ask: what if we built an engine that simply refused to quit? It just worked. Day after day, year after year, decade after decade. Taxi drivers put 500,000 miles on them without rebuilds. Farmers ran them until the frames rotted away. When the body gave up, they'd pull the engine, drop it in another car, and keep going. This was survival engineering at its peak. The Slant Six debuted in 1960 as Chrysler's compact car answer to the Volkswagen Beetle and economy imports threatening Detroit. It powered delivery vans, police cruisers, farm trucks, and sedans. While muscle cars grabbed headlines, the Slant Six made reliability legendary. It became the engine you handed down, the one sitting in a barn that fired up after 20 years. Mechanics didn't tear them down, they cleaned them up and put them back in. In an industry built on planned obsolescence and horsepower wars, Chrysler had created something eternal. That 30-degree tilt wasn't a gimmick. It was geometry in service of function. A lower hood line, better weight distribution, and a design that allowed the intake manifold to sit on the cool side while the exhaust baked on the hot side. Thermal efficiency without trying. Walk through any working-class neighborhood in 1968 and you'd find them everywhere. The postal worker's Dart, the insurance salesman's Valiant, the high school kid's Barracuda that wouldn't die. These weren't trophy cars. They were tools with 4 wheels. And underneath, that canted inline six hummed with the confidence of something built right. If you're enjoying these forgotten automotive stories, do not forget to subscribe. We're uncovering the machines that deserve to be remembered. The year was 1957, and Detroit was in crisis. American cars had grown into chrome-laden land yachts, heavy, thirsty, and out of step with a changing world. The Volkswagen Beetle was winning hearts with frugality. At home, recession made buyers rethink 8-cylinder extravagance. Chrysler needed a compact car and an engine to match. Enter Willem Weertman, a Dutch immigrant and Chrysler lifer. Weertman wasn't chasing horsepower or trophies, he was chasing durability. His mission: design an inline six that could survive anything the American driver could throw at it. Neglect, abuse, extreme temperatures. Do it while sipping fuel and fitting under a low hood. Weertman had watched engines fail. Head gasket failures from thermal stress, crankshaft failures from inadequate bearings, valve train carnage from poor lubrication. Chrysler's warranty claims piled up, costing millions. His mandate was clear: build something that doesn't come back, build it once, build it right, and make it last longer than the sheet metal. Chrysler's existing engines were tall. Inline sixes stood upright, their height dictated by vertical pistons and overhead valves. But compact cars demanded compact engines. The A-body platform hood lines were dramatically lower. A traditional inline six would create a massive bulge, destroying the sleek styling. Weertman's solution was audacious: tilt the entire block 30 degrees to the right. The rocker cover dropped below the hood line. The center of gravity shifted for better handling. Packaging became an advantage. Management thought he was crazy. The tooling costs would be substantial. But Weertman had done the math. The tilt wasn't just about clearance. It was thermal management, weight distribution, and serviceability. The slant allowed engineers to separate heat zones naturally. The intake manifold sat on the right side, away from exhaust heat. The exhaust manifold sat on the left, radiating away from critical components. No exotic materials, no complicated cooling loops, just physics. The result was an engine that ran cooler and suffered less thermal stress. Weertman and his team overbuilt everything. The block was thick-walled cast iron, nearly indestructible. Wall thickness in critical areas exceeded industry standards by 30%. The deck surface was machined to tolerances, ensuring perfect head gasket sealing after years of thermal cycling. This was generational thinking. The crankshaft rode on 7 main bearings instead of the typical 4. Overkill, but it meant the rotating assembly could handle punishment that would destroy lesser engines. Each main journal was 2.5 inches in diameter, massive for a 225 cubic inch engine. Mechanics would later discover you could stand on a Slant Six crankshaft without bending it. The valve train was simple: push rods, a single camshaft buried low in the block where heat and vibration couldn't touch it. No overhead cams to leak oil, no timing belts to snap, no variable valve timing to malfunction, just proven technology with obsessive attention to bearing surfaces. The cam lobes were induction hardened, a process reserved for industrial engines. This was an engine built to endure. Through oil changes ignored, through coolant left unserviced, through drivers who treated maintenance as suggestions, Chrysler bet that Middle America didn't want drama. They wanted to turn the key and go to work. They wanted an engine that started in Minnesota winters and survived Arizona summers. Development took 3 years. Prototype engines were subjected to torture tests that would destroy contemporary designs in hours. They ran them without oil until they seized, then freed them and ran them again. They cycled them from frozen to overheating repeatedly. Chrysler's durability standards for the Slant Six were twice as stringent as standards for V8 passenger engines. These would end up in commercial service, in rural areas far from dealerships with owners who couldn't afford breakdowns. But the performance crowd dismissed it. This was 1960. Horsepower sold cars. The Slant Six made 145 horsepower. Chevrolet's 283 small block made 230. Ford's 352 made 300. This was a workhorse in an era that worshipped stallions. Pull back the hood of a 1964 Dodge Dart, and you're looking at 225 cubic inches of industrial-grade stubbornness. The displacement came from a 3.4-inch bore and a long 4.125-inch stroke. An undersquare design prioritizing torque over revs. Peak torque arrived at just 2,400 RPM. You didn't wind it out, you didn't need to. The block was a fortress. 7 main bearings cradled the crankshaft. Engineers did this for immortality. More bearings meant load distribution, less stress per journal, longer life between failures. The cylinder head was a single casting. Wedge-shaped combustion chambers promoted efficient flame travel. The combustion chamber volume achieved an 8.4-to-1 compression ratio, high enough for efficiency, low enough for regular fuel and durability. Valves were small by muscle car standards, 1.78 inches on intake, 1.5 on exhaust. This wasn't about peak horsepower, this was about consistent, usable power. The valve springs were over-engineered, dual springs with dampers rated for sustained operation beyond the 4,000 RPM redline. Most drivers never saw 3,500, but Chrysler built for the teenager who would. Cooling was where the tilt paid dividends. The water pump sat low, driven directly off the crankshaft. Coolant flowed upward through the block around cylinders into the head. The passages were generous, designed to handle partial blockage from neglected coolant. The oiling system was brilliantly simple. A gear-driven pump sat at the front, pulling from a deep sump and pushing through full-flow filtration. Oil pressure at idle was typically 35 to 40 psi, climbing to 60 psi at cruising. The system maintained 10 psi minimum even with worn bearings, enough to prevent metal-to-metal contact. The cam and lifters rode on splash lubrication, archaic by modern standards but nearly bulletproof. Oil flung from the crankshaft coated everything. No pressurized galleries. To clog. Mechanics tell stories of Slant Sixes found bone dry, seized solid that were freed with penetrating oil and ran again. Fuel delivery was carburation. A single-barrel Holly or Carter sat atop the intake, mixing air and fuel with mechanical precision. No electronics, no computers. If it ran rich, you adjusted the mixture screw. If it ran lean, you checked for vacuum leaks. Shade tree mechanics could tune a Slant Six with a screwdriver. The carburetor had maybe a dozen moving parts. Everyone could be replaced in a driveway. Magazines noted the engine's remarkable lack of vibration. That 7 main bearing crankshaft was balanced to a degree unusual for a utility engine. Chrysler knew these would idle for hours in taxis and delivery trucks. Smoothness wasn't luxury, it was durability. Less vibration meant less fatigue on mounts, less stress on brackets, longer life for everything bolted to the block. By 1970, the Slant Six had a problem. It was too successful at being invisible. While Chrysler's muscle cars grabbed magazine covers and drag strip victories, the Slant Six toiled in obscurity. It powered cop cars and postal jeeps. It was the engine nobody bragged about, and in the horsepower-obsessed late 60s, that was a death sentence for respect. Young buyers wanted quarter-mile times and tire smoke. The Slant Six just hummed. The muscle car era had created a generation that measured automotive worth in horsepower per dollar, and by that metric, the Slant Six was worthless. Internally, the engine faced existential threats. Emissions regulations were tightening. The Clean Air Act of 1970 demanded catalytic converters, unleaded fuel, and reduced compression ratios. The Slant Six's simple design would struggle to meet evolving standards. Meeting regulations would require air pumps, EGR valves, catalytic converters, and eventually fuel injection. But Chrysler's resources were stretched thin. The company was pouring money into big block development. The bean counters saw a profitable product that didn't need fixing. Why spend millions redesigning something that worked? Upgrades were delayed, budgets cut. Development froze while the regulatory environment evolved. Engineers had proposals for fuel injection, aluminum cylinder heads, electronic engine management. The aftermarket had proven turbocharging worked beautifully. With modern technology, the Slant Six could have been transformed, but corporate priorities lay elsewhere. The Slant Six would soldier on with 1960 technology. Then came the insurance crisis. By 1972, muscle cars were strangled by skyrocketing premiums. Young men couldn't afford insurance on 400 horsepower machines. The horsepower wars collapsed. Suddenly, the industry needed exactly what the Slant Six had been: economical, reliable, insurance-friendly transportation. But Chrysler had starved it of development. The 1973 oil crisis delivered another blow. Gas prices doubled, then tripled. Lines formed at stations. Fuel economy mattered more than quarter-mile times. The Slant Six should have thrived. It was economical compared to big blocks, but it was also heavy, technologically stagnant, and less efficient than modern four-cylinders from Japan. A Toyota Corolla returned better mileage and made nearly as much power from half the displacement. Honda, Toyota, and Datsun flooded showrooms with efficient modern engines that made the Slant Six look agricultural. The tilt that once seemed clever now seemed quirky. The cast iron that once meant durability now meant weight. The Slant Six was becoming a relic. Inside Chrysler's engineering halls, arguments raged. Some wanted to modernize, add fuel injection, aluminum heads, overdrive transmissions. Others argued for replacement. The bean counters did the math. The Slant Six was too cheap to kill, but too old to save. The tooling was paid for, the assembly lines efficient. Killing it created short-term pain. Modernizing required capital with uncertain returns. So it persisted in zombie form, neither alive nor dead. The press began writing obituaries. Motor Trend called it the engine that defined an era we're leaving behind. Car and Driver noted its admirable simplicity in an age demanding sophistication. The message was clear: durability wasn't enough. The market wanted efficiency measured in EPA numbers, not owner testimonials. Production numbers told the story. In 1970, Chrysler installed Slant Sixes in over 300,000 vehicles. By 1975, that fell below 200,000. By 1980, under 100,000. The engine was being phased out with a long, slow decline. Fleet buyers still specified them, but the consumer market had moved on. The Slant Six's fate was sealed not by engineering failure, but by cultural evolution. It had been designed for an America that changed oil regularly and kept cars for decades. It was being phased out for an America that leased cars and expected technological obsolescence. When Chrysler discontinued the Slant Six in 1983, the automotive press barely noticed. No farewell editions, no commemorative plaques. It simply stopped appearing on option sheets. After 23 years and over 3 million units, America's most indestructible engine exited quietly. The final Slant Six rolled off the Trenton engine plant assembly line on a Thursday afternoon. No ceremony marked the occasion. The workers didn't know it was the last. It was installed in a Plymouth Reliant wagon, painted forgettable beige. That engine is probably still running somewhere, unaware it represents the end of an era. But in driveways across America, the Slant Six refused to acknowledge its obsolescence. Used car lots were full of Valiants and Darts with 200,000 miles and counting. Taxi companies kept them running well into the 90s. Fleet maintenance records show properly maintained Slant Sixes routinely exceeded 300,000 miles. Some surpassed 500,000. New York City taxi operators were particularly devoted. Through the 1980s, yellow Dodge Aspens and Plymouth Valaris with Slant Sixes remained common, racking up miles and punishing urban service. According to a 1985 fleet manager, their Slant Six taxis averaged 375,000 miles before retirement, and retirement meant the body had rusted through, never engine failure. We pulled engines with 400,000 miles that still had compression within 5% of spec. It was absurd. We couldn't kill them. The aftermarket responded with a curious phenomenon. There wasn't one. Slant Six parts didn't fly off shelves because Slant Sixes didn't break. Rebuilders kept small inventories. Machine shops rarely saw them. When they did, it was preventive maintenance on engines approaching lunar mileage. A Pennsylvania engine builder recalled, "We'd get one every few months, and 9 times out of 10 it just needed rings and bearings. The block, the crank, the rods, everything else was still within spec. Easiest rebuilds we ever did." Enthusiast culture largely ignored the Slant Six through the 80s and 90s. Hot rodders wanted V8s. Restorers wanted Hemis. The Slant Six existed in mechanical purgatory. Too common to be collectible, too reliable to be interesting, nobody was restoring a Slant Six Valiant for Pebble Beach. Yet stories accumulated. Folklore. The Dodge Dart that sat in a barn for 15 years and started on the 3rd crank. The Plymouth van with 400,000 miles that didn't burn oil. The winter of '78 when nothing started except the Slant Sixes. These tales circulated among mechanics, not as legend, but as lived experience. Industry analysts published retrospectives examining why the Slant Six faded. The consensus was damning. It had been too good for its own survival. Chrysler made no money on warranty repairs because there were none. It made no money on replacement engines because originals wouldn't die. The Slant Six had succeeded so completely it became economically irrelevant. A 1988 SAE paper used the Slant Six as a case study, noting its longevity reduced Chrysler's profitability in the replacement parts market. Customers who kept Slant Six cars running for 15 years weren't buying new Chryslers. The paper concluded that moderate durability optimized for customer satisfaction was more profitable than extreme longevity. Building engines that lasted forever was bad for business. Salvage yards told their own story. Through the 90s, junked Slant Six cars arrived with pristine engines. The rust had won. The transmission failed. The electrical system corroded. But the engine still running. Yards began pulling Slant Sixes as cores, selling them to rebuilders, marine converters, and industrial users. A 200,000-mile Slant Six from a rotted Valiant had commercial value. Junk yards reported selling the same Slant Six 3 or 4 times over 20 years, pulled from successive vehicles as each fell apart around it. Somewhere in the early 2000s, the Slant Six stopped being a joke and started being a philosophy. Enthusiasts who'd watched their father's Darts refuse to die began seeking them out deliberately. Not for speed, not for show, but because in an automotive landscape dominated by disposable technology, the Slant Six represented permanence. The internet changed everything. Forums emerged where owners documented their engine's achievements. Posts detailed 400,000-mile odometers, engines pulled from floods that ran again, builds that made surprising power. The community wasn't large, but devoted. These were engineers, pragmatists, and old-school hot rodders who saw beauty in simplicity. Modern engine swaps began flowing in reverse. Where hot rodders once pulled Slant Sixes to install V8s, a new generation started pulling modern engines to install Slant Sixes into trucks, off-road rigs, boats, and industrial equipment. The reasoning was bulletproof. In remote locations, simplicity trumped power. You couldn't diagnose a computer-controlled engine with a screwdriver, but a Slant Six? You could keep it running with hand tools. Overlanders and adventure vehicle builders discovered the Slant Six through necessity. As expedition culture grew, operators looking for reliable power plants rediscovered what commercial operators knew: the Slant Six would run anywhere, on anything, with minimal support. reports emerged of Slant Six-powered trucks in South America, Africa, and Australia, running on questionable fuel and infrequent maintenance, outlasting modern engines requiring dealership computers. The industrial world never forgot. Through the 90s and into the 2000s, Slant Sixes continued powering forklifts, generators, and irrigation pumps. Marine conversion companies still offered Slant Six packages. The engine's overbuilt bottom end and tolerance for neglect made it ideal where failure meant financial catastrophe. One Louisiana fishing boat operator ran a Slant Six for 12 years in a commercial shrimp trawler in the Gulf of Mexico. Saltwater spray, constant vibration, heat, humidity, 6 days a week, 10 hours a day. Change the oil every 50 hours, freshwater flushed the cooling system every trip, and that was it. When I sold that boat, the engine was still making full compression. The boat had rusted out around it. I sold the engine separately for more than the boat. Restorers began appreciating survivor cars with original Slant Sixes. At car shows, a numbers-matching 1965 Barracuda with its original 225 and documented 300,000 miles became more interesting than a clone with a crate Hemi. These engines told a story modern machines couldn't. An era when engineers built for decades, not lease cycles. Performance enthusiasts discovered the Slant Six responded to modification. The overbuilt bottom end made it perfect for forced induction. Turbocharger kits began appearing, pushing 20 pounds of boost through engines designed for atmospheric pressure. And they held. Owners documented 300 horsepower builds on stock internals, perfectly reasonable for a block designed with 7 main bearings and massive safety margins. The Australian connection proved crucial. Chrysler Australia continued producing Slant Sixes through 1981, developing performance parts for racing. Australian racers campaigned Slant Sixes in touring car competition. American enthusiasts began importing Australian parts, building Slant Sixes making respectable power while retaining factory durability. With turbocharging, 400 horsepower wasn't uncommon, from an engine originally rated at 145. Chrysler's engineers reflected on the Slant Six's legacy. One retired powertrain engineer explained, "We built it to survive the average American driver, which meant assuming the worst. No maintenance, heavy loads, extreme temperatures, so we over-engineered everything. Looking back, we probably went too far, but that's why they're still running." Another engineer noted the Slant Six represented a design philosophy no longer economically viable. "We built that engine with bearing surfaces and wall thicknesses that added cost but ensured longevity." Modern engines are optimized for the warranty period. Build them strong enough to last 150,000 miles, but not so strong you add unnecessary cost. The Slant Six was built to last 500,000 miles. That's not good business. The contrast with modern engines became impossible to ignore. Today's power plants make triple the horsepower from half the displacement and achieve emissions levels unimaginable in 1960. They're technical marvels. They're also unrepairable outside dealership service bays and economically totaled at 150,000 miles. The Slant Six represented a different calculus, one prioritizing longevity over efficiency and owner agency over manufacturer control. Modern engines are sealed systems. Plastic covers hide components. Specialized tools are required for basic service. Diagnostic computers are mandatory. The Slant Six was naked mechanical honesty. Everything visible, accessible, repairable with hand tools. You could trace the entire oiling system visually. There was no mystery, no proprietary knowledge, no the dealer monopoly on service. It was democratic engineering. By the 2020s, the Slant Six had achieved mechanical sainthood. It transcended its original purpose to become a symbol of durability over disposability, a symbol of owner autonomy over manufacturer control, a symbol of an engineering philosophy prioritizing the long-term over quarterly earnings. In debates about vehicle reliability, the Slant Six became shorthand for they used to build them to last. The sound of that engine wasn't just reliability cast in iron, it was a promise that machines could be built to last, if someone decided they should. What began as a pragmatic answer to compact car requirements became a testament to engineering honesty. The idea that durability wasn't a luxury feature but a fundamental responsibility. The Slant Six proved you could build an engine that refused to break, that owners could fix, that would outlive the cars it powered and the company that built it. In an industry embracing disposability as a business model, that's not just legacy, that's rebellion. Return to that 1965 Valiant in the driveway, 20 below. No pity, no excuses, just the sound of an engine that knows exactly what it is, this cast iron, steel, and stubborn refusal to acknowledge limitations. Turn the key. It starts, of course it starts, it's a Slant Six. For over 2 decades, Chrysler built an engine prioritizing survival over spectacle. The Slant Six wasn't just transportation, it was proof that engineering integrity could exist in economy cars, that durability could be designed in, that a machine could be so fundamentally sound it would outlast the era that birthed it and the company that built it. We live now in an age of disposable complexity. Engines making astonishing power but requiring dealer-level diagnostics to repair. Cars designed for lease cycles, not lifetimes. Power plants economically totaled at 150,000 miles, not because they're broken, but because they're too complex to fix economically. The Slant Six stands as a counterpoint, a reminder that it's possible to build machines owners can understand, maintain, and trust for hundreds of thousands of miles. Not because they're simple, but because someone decided they should be. Someone decided a taxi driver in New York deserved an engine that wouldn't strand them, that a farmer in Kansas deserved a truck that would start in February. If you've ever turned the key on a Slant Six and heard that immediate, unshakable idle, you know what permanence sounds like. It's not loud, it's not dramatic, it's the sound of something that has no intention of quitting. That steady, mechanical hum that says, I was built right, I will run until the metal itself fatigues, and even then I'll probably run a little longer. If you've watched one start after years of neglect or run perfectly at 300,000 miles, you understand why mechanics speak of them with reverence. They've seen everything. And then a Slant Six comes in with 400,000 miles and all it needs is a tune-up. It challenges their assumptions about mechanical mortality. It proves longevity isn't luck, it's design. And if you still drive one, you're carrying forward a philosophy the modern automotive world has largely abandoned, the belief that machines should be built to last and that reliability isn't a feature, it's a promise. Every time you start that engine, you're voting for a different kind of future. One where things are built to endure, where owners have agency, where durability is valued over disposability. The Slant Six proved it was possible. Engineers at Chrysler in 1960 sat down and decided to build an engine that would outlast everything. And they did. They succeeded so completely their creation became its own reward. A machine that asked for little and gave everything. That required only basic care and delivered decades of service. That could be understood by anyone willing to lift the hood and look. Share your Slant Six story in the comments. The miles, the punishment it endured, the moment you realized it would outlive you. These engines deserve documentation because they represent something we're losing. The idea that engineering can be an act of respect for the people who depend on it. That durability is a moral choice, not just an economic calculation. That building things to last is possible if we decide it matters. Thanks for watching, and I'll see you in the next video.